If you are a software developer who wants to move into fintech, the hardest part usually is not the programming. It is knowing which layer to build first, and everything looks equally urgent. Should you learn banking, payments, trading, financial markets, cloud infrastructure, security, accounting? Every path looks equally important, and that is exactly what stalls people for months. A strong fintech engineer is built in layers, 12 of them. Each one assumes the layer below it already works, which is why the order matters more than the speed. Layer 1 is backend engineering. Fintech systems are heavily backend driven. A request crosses an interface, a service, a database, a queue, and a worker before anything is final. So, what happens when that request fails halfway through? The account is already debited, the network drops, and the client retries. That is not a glitch. That is a financial event. The language matters far less than the fundamentals. Node, Python, Java, Go, they all lead to the same requirement: systems that are predictable, testable, and reliable under load. Layer 2 is databases. You should understand relational databases extremely well because in finance, the schema is where meaning is enforced rather than merely stored. Two payment requests hit the same account at once. Both read a balance of 100. Both spend 80. Without locking, you have just gone 60 below zero. So learn transactions, indexes, locking, constraints, isolation, and consistency first. Caches, queues, and analytic stores come later, once the relational core is genuinely solid. Layer 3 is money. 0.1 plus 0.2 does not equal 0.3 in floating point. Money is not a float, and that is not a rounding curiosity. Precision is business logic. Dollars take 2 decimals, yen take none, dinars take 3. Rounding rules belong in the contract, not in whichever column type you happen to pick. Layer 4 is ledgers. A naive system stores a balance of 900. A good one can explain why that balance is 900, entry by entry. Every movement leaves evidence. A transfer is not one update. It is a balanced pair. One account debited, another credited, and the two are required to agree. That is what gives you auditability. Months later, somebody asks what happened, and the system reconstructs the answer from its entries instead of guessing. Layer 5 is reliability. A phone sends a payment, the response is lost, and the phone retries. Should the customer be charged twice? No, never. An idempotency key is how you prove it. The same key means the same operation and one financial effect, no matter how many times the request actually arrives. Layer 6 is your domain. Do not try to learn all of finance at once. Payments, banking, lending, markets, wealth. Pick one and go genuinely deep. Payments is a chain: customer, merchant, processor, bank. Authorization, capture, refund, chargeback, and settlement each mean something precise, and confusing them is expensive. Banking is accounts and movement: transfers, the ledger behind them, reconciliation against the outside world, and interest applied correctly over time. Lending is a decision engine. Income, debt, and credit history go in. Approve, review, or reject comes out, with risk priced into the result rather than assumed away. Markets are events: trades, quotes, order books, exchanges, market data, and settlement. Each is a different record with different guarantees behind it. Wealth is composition over time: a portfolio, its allocation, its risk, the rule that rebalances it, and performance you can actually defend to somebody else. Whichever you pick, build something real in that one domain first. Specialize, build, then expand. Breadth without depth teaches you surprisingly little. Layer 7 is financial data. Markets emit trades and quotes. Payments emit authorizations and settlements. Lending emits applications and repayments. Different streams, different rules. And context changes meaning. The same number can be a balance, a price, or a spread in basis points. The number by itself tells you almost nothing. Layer 8 is security. Authentication, authorization, encryption, secrets, rate limits, and audit logs wrap the system, because in fintech, the consequences are immediate. 3 questions, not one. Who are you? What are you allowed to do? And should this particular action happen at all, given everything else we know? Layer 9 is cloud and distributed systems. Modern fintech has to process large volumes of events reliably. Interfaces, queues, workers, caches, and an event bus. But do not worship microservices. One clean modular application beats 20 tangled services every time. Complexity must earn its place. Layer 10 is observability. Most dashboards watch load, memory, latency, and errors. That is useful, but it is only half of the picture you actually need. You also need decline rates, settlement delay, reconciliation mismatches, and duplicate transactions. Is the server alive is a different question from is the system correct? Layer 11 is testing. The usual pyramid still applies, but around it sits another layer entirely, the financial invariants that are never allowed to break. Debits equal credits. One request produces exactly one effect. Portfolio weights sum to 100%. A reversal restores the original balance. Test business truth. And financial bugs live in the edge cases: zero, negative, duplicate, out of order, missing, oversized, wrong currency, closed market. Those are the real cases. Layer 12 is projects. Another to-do application proves nothing here. Build financial systems and let them fail in ways that you can explain afterwards. Project 1 is a wallet and ledger, accounts, transfers, balanced entries, a derived balance, and reconciliation, with double entry and idempotency built in from the start. Project 2 is a payment simulator, authorization, capture, failure, retry, refund, and routing, so the lifecycle becomes something you have actually operated rather than read about. Project 3 is a market data pipeline. Ingest the ticks, normalize them, validate them, build candles, detect the gaps, and store the result together with its lineage. Project 4 is portfolio analytics, returns, volatility, drawdown, correlation, and a risk-adjusted measure, each computed from a basis you have declared explicitly. Then the bigger ones: a lending engine, a trading platform, a robo-advisor, fraud detection. Each should show the failures handled, not only that the happy path works. So the roadmap looks like this: backend, databases, money, ledgers, reliability, domain, data, security, cloud, observability, testing, and projects. 12 layers in that order. And that is the real difference. A developer asks how to implement this. A fintech engineer asks what the rule means, how the system should behave, and how we prove it was correct. Financial meaning plus engineering behavior plus production evidence. That combination is what fintech engineering actually is, and each part is learnable. Concepts, algorithms, data contracts, interfaces, implementations, and tests. Understand it, build it, and then prove it. That last step is the one most people skip. So go back to where you started, choose a single branch, and take it seriously. Not everything at once, one layer at a time. Welcome to the Fintech Builder, where we build financial systems from first principles.